Hello, everybody. Today we are here. I'm here with Luna the Math Cat, and we're going to talk about the triangle sum theorem today, which is notice there's a bunch of stars here because that's a super important theorem. Okay, so what is the triangle sum theorem? Well, it says the sum of the measures of the angles of a triangle is 180 degrees. Okay, so a lot of you already knew that. We're going to prove it right now. Okay, so I've set up my proof here. I've got my given, I've got triangle ABC. So here's triangle ABC. And I've drawn line M. This is line M so that it's parallel to AB. Notice I got my parallel marks on here. I went ahead and labeled the angles 1, 2, 3, 4, and 5 like this. Okay, and so in order to prove the triangle sum theorem, we need to show that angle 1 plus angle 2 plus angle 3 is 180 degrees. Okay, so here we go. So here's what we do know. We know that angle 4 plus angle 2 plus angle 5 adds up to 180 degrees. Now, how do we know that? Well, they form a straight line. These three angles together form a straight line. Okay, so we're just going to use that as our justification. They form a straight line. And we already know that there's 180 degrees in a straight line, at least in the angle. Okay, so what else do we know? Well, we know this. We know that angle 1 is equal to angle 4. Notice I marked it on the picture. Okay, angle 1 is equal to angle 4. And how do we know that? We know that parallel lines, whoa, can't write today. Let's try that again. Parallel lines imply that alternate interior angles are equal. Okay, so we proved that last time. All right, we also know, yeah, that's true. We also know that angle 3 and angle 5 are equal angles. Okay, so angle 3 is equal to angle 5, and that's the same reason. Parallel lines imply alternate interior angles are equal. Okay, so now we know that 4 plus 2 plus 5 is 180. We know that 1 and 4 are equal, and we know that 3 and 5 are equal. So here's what we get to do. We get to do a little substitution. Since 1 and 4 are equal, we can take angle 4 out and put angle 1 in its place, which makes angle 1 plus angle 2. Now, we're going to do the same thing with 5 and 3. Okay, so we know that 3 and 5 are equal, so we're going to take angle 5 out, and we're going to put 3 in its place, plus angle 3 equals 180. Okay, and our reason for that is substitution. Substitution just says take one thing and replace it with something that's equal to it. Okay, we just proved our theorem. We showed that angle 1 plus angle 2 plus angle 3 is 180. I didn't say anything about the triangle. It was any old triangle. Okay, so this works for all triangles. Actually, this works for all triangles in a plane. Okay, so be careful about that, because if you change the rules of the game and we do like spherical geometry, this is no longer true anymore. But in plane geometry, not meaning boring geometry, but flat surface geometry, this is a true statement. So we proved our theorem. So we get to write down here QED, quad erat demonstratum, and we are done. Okay, moving right along. Theorem: if two angles of one triangle are congruent to two angles of a second triangle, then the third pair of angles must be congruent. Okay, so here's what I have. I have triangle QRS, okay, and I have triangle MNP. And I know that angle R is equal to angle N. So I'm going to go ahead and put that on my picture like this. And I know that angle S is equal to angle P. So I'm going to go ahead and put that right here like this. Now that's my given, okay? Some teachers like you to put your given down here. I don't ask you to do that. It's right there, so you don't need to do that. Okay, so what do I know? Well, I know this. I know that angle Q plus angle R plus angle S is equal to 180 degrees because of the triangle sum theorem that I just proved. Triangle sum theorem. Okay, I also know that the angle M plus angle N plus angle P is also equal to 180 degrees for the same reason. So let's take this and we'll clone it, put it right there. Okay, so I know those things are true. Now, here's the deal. I know that these three angles equal 180, and I know that those three angles equal 180. So here's what I can do. I can take these three and set them equal to these three. So angle Q plus angle R plus angle S is equal to angle M plus angle N plus angle P. That is, remember the transitive property. Remember that said that if A is equal to B, here's A is equal to B and B is equal to C, then A and C must be equal. Okay. Now, I can do a little bit of substitution here. Okay. So I know that angle R and angle N are the same. So you know what I'm going to do? I'm going to take angle N out over here, and I'm going to make that angle R. And I also know that angle P is equal to angle S, so I'm going to take angle P out over here. I'm going to put angle S in its place. And then I have this. Okay, these three angles are equal to those three angles. That's by substitution. Okay, now you can probably see where I'm going to go right here. I can do this. I can say, well, I've got an angle R on both sides, so I'm going to subtract it from both sides. And I've got an angle S on both sides, so I'm going to subtract that from both sides. And what do I get left? Angle Q is equal to angle M. Subtraction property of equality. And, oh, look at this. That's what I wanted to prove. So I'm done. I proved it. QED. So I've now proved that if two triangles of one triangle are equal to two angles of another triangle, then the third set of angles need to be equal. Okay? And I can go ahead and mark that on my picture right here. Okay. Properties of special triangles. All right. What are special triangles? Well, you got an isosceles triangle. Let's talk about the parts of a isosceles triangle. So you have something called the vertex. Notice it's capital T, capital V. This is the vertex right there. The vertex is the point where the two equal sides meet. And we shouldn't say the point. We should say this right. We should say the vertex. No, we already got them. Well, that's fine. There's 3 vertices here. What in the world? There's 3 vertices, 1, 2, 3, but this is the vertex right here. Okay, the legs. The legs are the 2 sides that are equal. Okay, so here's a leg, and here's a leg. I know they're equal because they both have 2 marks on them. Okay, the base. The base is the side that's not a leg. Okay? It's the side that is not equal. Okay? Now, if it's an equilateral triangle, sometimes they say an isosceles triangle is a triangle with at least 2 sides equal. Okay? And that's fine. In that case, the base is the side that's on the bottom. Okay? Because then an equilateral triangle would also be isosceles. All right, the base angles. This is important because this one comes up all the time. The base angles are the 2 angles that have the base as a side. Okay, so here's a base angle, and here's a base angle. So we could say base angles. That's that one and that one. And of course, that means that the other one's the vertex angle. So the vertex angle is the angle formed by the 2 legs. You could also say it's the angle at the vertex, capital T, capital V. Vertex angle. Okay, and I guess I should have said that this is the vertex. Right there. Okay. And then we have a nice little postulate here. Remember, a postulate is something that we're going to accept to be true without proof, and that's that the base angles of an isosceles triangle are congruent. Okay, so make sure you know that. I would know this right here. That beautiful rainbow. Okay, the base angles of an isosceles triangle are congruent. We are going to use that a lot, so make sure you know it. All right, moving right along. Find the measure of angle A. Remember, this means measure of angle A, and the measure of angle C. Okay, so here's the thing. You might want to pause the video and figure this out yourself. See if you can do that right away. Yeah, go ahead and do that. Go ahead and pause the video and do both of these problems, okay? So here I have the vertex angle is 28 degrees, and here I have one of the base angles is 25 degrees. See if you can figure out all the other angles in both those triangles, and then jump back on and see how you did. Okay, so up here on this one, remember there's 180 degrees in a triangle, and we've used 28 of them right here. So we're going to go ahead and take those 28 out. And what does that leave? That leaves 152. Okay? So I have to have 152 degrees at these two angles. Now, I know from the previous page that the base angles of an isosceles triangle are equal. So we're going to go ahead and take this 152 and divide that by 2, and that's going to be 76. So there's 76 degrees here, and there's 76 degrees here. So the measure of angle A is 76 degrees, and the measure of angle C is also 76 degrees. Okay, now down here on this one, we know a base angle, okay? And remember, the base angles of an isosceles triangle are congruent. So if this one's 25 degrees, this is the other base angle, it has to be 25 degrees as well. So we know right away, real easy, that angle L, the measure of angle L, has to be 25 degrees because the base angles of an isosceles triangle are congruent. Okay, now I also know that there is 180 degrees in every triangle. And I've used 25 of them here and 25 of them there, so I've used 150 degrees. That means the remaining 130 degrees must be right here. Okay, so the measure of angle K has to be 130 degrees, and I'm done. Okay, got both the angles. So hopefully you got that as well. Okay, postulate. If a triangle has two congruent angles, then it must be isosceles. So here's the thing. In this picture, I've got two congruent angles. That's telling me this has to be isosceles. And the sides that are equal will always be across from the equal angles. So that side right there will be equal to that side right there. Okay? So first we're going to find the measure of angle R. That's super easy. We're going to go ahead and take 180 degrees. We're going to subtract 48. Okay, so that leaves what, 132? And we're going to subtract 48 again. Okay, so that's going to leave 84 degrees. And so this has to be 84 degrees right there. Okay, so we know that measure of angle R equals 84. Done with that. Find RS, that's simple. RS is 5 centimeters because it has to be equal to this one right here. Now, this side right here, we don't know. We're going to have a theorem a little bit later that will give us a range of values for this, but we don't know what that is just yet. Okay? All right. So here we go. Got a little assignment for you. Good luck, and I will see you guys later.